Okay, I'm going to talk through some of the examples or the problems from tonight's homework for practice for your test. So, number 1, I want you to find P of 4a. And so we're going to use P of x is 3x squared minus 4. And we're going to take 4a and plug it in for the x. So I get 3 times 4a squared minus 4. And remember that 4a squared means 4a times 4a, and that is 3 times 16a squared minus 4, and that's 48a squared minus 4. And that's your final answer there. Okay. Number 2 is asking us to find r of 4, so we're going to use r here and plug in 4. Then we'll find q of negative 2, we'll plug negative 2 in here, and then we'll add our two results. So r of 4, that's the square root of 2 times 4 plus 1 plus 5 outside the absolute value, which is the square root of 8 plus 1 is 9, plus 5, which is 3 plus 5, 8. And now we'll find q of negative 2, absolute value of 3 times negative 2 minus 7 plus 1. That's the absolute value of negative 6 minus 7 plus 1, which is the absolute value of negative 13 plus 1, which is positive 13, because negative 13 is 13 units away from 0, and that is 14. So now I'm going to add 8 plus 14 to get 22. So that was number 2. Number 3, I'm going to do negative 5 times q, which is the absolute value. So let's put this in brackets. Absolute value of 3x minus 7 plus 1. Close the brackets. The 5 gets distributed in front of the absolute value and to the 1. So I get negative 5, absolute value of 3x minus 7. Close the absolute value. Negative 5 times 1 is minus 5. So that is your final answer for number 3. And then number 4 we'll do on here. P of x minus 2, that means we're going to take x minus 2 and plug it in for the x right here. So I get 3 times x plus 2 squared, and then it's minus 4. X plus 2 squared, you have to FOIL that out. You should get x squared plus 4x plus 4 by multiplying x plus 2 times x plus 2. And I get 3 times x squared plus 4x plus 4, and then minus 4. And then that's 3x squared plus 12x plus 12 minus 4. And that's 3x squared plus 12x plus 8. And that's our final answer for number 4. Okay, so now we're going to look at number 5, q of x minus 3 plus 1. So q, number 5 here, q is the absolute value of 3x. X is going to get replaced with the x minus 3 minus 7 plus 1. That's the absolute value of 3x minus 9 minus 7 plus 1, which is the absolute value of 3x minus 16 plus 1. And that's all I did here was the q of x minus 3, so now I still have to do this plus 1. And so I get the absolute value of 3x minus 16 plus 2. So it's probably a good idea to write the plus 1 in the beginning so you don't forget it. And number 6. 5 times r of 3a. So first I'm going to do r of 3a. So that's the square root of 2 times 3a plus 1. That's not getting distributed. It's just the 3a that gets multiplied, and it won't erase. There we go. And then plus 5, I believe. Hold on, I gotta move it, I can see. Plus 5. And so that's the square root of 6a plus 1 with a plus 5 outside. Now I'm going to multiply it by 5 because it was 5 times r of 3a. So I'm going to times this by a 5. I'm going to put brackets here so we remember that I'm multiplying both the 5 to in front of the radical, and then I'm multiplying the 5 to the 5 on the outside. So I get the final answer 5 radical 6a plus 1 plus 25. That's my final answer there. This radical looks funny. Okay, number 7 is 3q times 2x. 3 times q of 2x. So I need some space here, hold on. Okay, number 7 is 3 times q of 2x. So I'm going to take the 2x and plug it in here for the x. Absolute value of 3 times 2x minus 7 plus 1. And then we're going to multiply it by the 3. So we get 3 times the absolute value of 6x minus 7 plus 3. And that's because the 3 goes in front of the absolute value and it distributes to the 1. So that's your answer. Number 8 says negative q of x plus 4. So it's negative times the absolute value of 3x minus 7 plus 1, and then plus 4 on the outside. So after I distribute my negative in front of the absolute value and to the 1. So negative absolute value of 3x minus 7 minus 1 plus 4 is negative absolute value of 3x minus 7 plus 3. That's your answer, number 8. Okay, so now we're describing the transformation in academic language, meaning we're saying horizontal translation, we're saying vertical shrink and stretch, we're saying reflection in the x-axis or reflection in the y-axis, and we're saying vertical translation up and down. We're not just saying right, left, up, down, shrink, stretch. We're using the academic language and we're using the correct order. So number 9 is g of x minus 2. When it's inside the parentheses and it's added or subtracted, it's a horizontal translation. So we have let's just type it to make it look nicer, a horizontal translation right 2. And that is super small. Let's see if we can make this bigger. There we go, that's better. Okay, that's a horizontal translation, right 2. Now, number 10. We have nothing inside the absolute value, so there's no horizontal translation. We talk about the shrinks and stretches first. because 2 is greater than 1. This is a vertical stretch, factor of 2. Then lastly, we'll talk about the minus 4, which moves it down 4. So let's see. A vertical stretch factor of 4. Then we have a vertical translation down 4. Okay, number 11 is y equals x plus 3. The plus 3 is horizontal and it's going to be left 3. And the plus 1 on the outside is a vertical translation. So we have a horizontal translation, left 3, and a vertical translation, up 1. Number 12, negative h of x minus 5. The negative outside of the function is a reflection in the x-axis, and then minus 5 is a vertical translation down 5. So we have a reflection in the x-axis and a vertical translation down 5. Number 13, the x plus 3 on the inside, horizontal. It's added, so it's a translation, and it's opposite, so it's going to go left 3. And then we have a vertical shrink because 1/2 is between 0 and 1. A vertical shrink there. So we have a horizontal translation, left 3. And we have a vertical shrink factor of 1/2. Number 14, when we have a negative inside the function, that is a reflection, a negative on the variable, that's a reflection in the y-axis. So that's a reflection in the y-axis, and then the plus 2 is a vertical translation up 2. So we have reflection in the y-axis and then a vertical translation up 2. And the last one, this 4/3 in front is a vertical stretch because 4/3 is greater than 1. So we have a vertical stretch factor of 4/3, and then we have the negative on the inside, which is a reflection in the y-axis. Okay, and those are the orders. So the order is horizontal translations, shrinks and stretches, reflections, and then vertical translations. Okay, so we're looking at domain and range here. Domain is the x values, so we can see on this graph my x's start here and go that way continuously because of the arrows, and my y values fill up the whole thing because this keeps going and that keeps going, so it's going to be the entire axis, which means the range is y such that y is contained in the set of all real numbers. And this stylus is doing some really crazy things to me right now. And then the domain, this is 1, 2, 3, -3, and it's that way to the right. Those are all the numbers greater than, so x such that x is greater than or equal to -3. Okay, let's look at number 17. The x's start here, and they go all the way to here, which is -3 to +2. So my domain is x such that -3 is less than, because it's an open circle, x less than or equal to 2. And then my range, let's look at that. It starts down here at -1 and it goes all the way up to a +1, 2, 3, 4. So we're going to say y such that -1, is less than or equal to, because our closed circle here, y, which is less than 4, because at 4 up here we have the open circle. Is it a function? Are they a function? The first one, number 16, is not a function because when I take a vertical line, it touches the graph twice. So this is not a function. But if I draw several vertical lines through the function on 17, it only touches the graph at one time, so it is a function. Number 18, my y values, or my x values here, my domain, are just going to be individual values. I have x such that x equals -4, -2, 0, and 2. And my y's are -2, 0, 2, and 5. So y such that y equals -2, 0, 2, and 5. And at this point here, a vertical line touches 2 points. Therefore, this is not a function. And then our last one, number 19, my x's start here and they go less than, so that's a 2. So my domain is x such that x is less than 2. It's not or equal to because it's an open circle. And my y starts here at -1 and goes up. So I have y such that y is greater than -1. And it is a function because a vertical line would only touch the graph at one point in time. All right, we're going to graph 20 through 22. Your vertex comes from your x value here, this number inside, and its opposite, so +3 instead of -3. And then our y value of our vertex comes from the number on the outside, so comma 1. That's where I'm going to start my graph, at +3, +1. And then my rise over run is the number in front, which happens to be a 1, so it's up 1 over 1. I can't get that to work. Up 1 over 1, up 1 over 1. And then I go the other way, up 1 and left 1, up and left, until I have a V. So it's really important that you not make these lines. These are not linear functions, they are graphs. Or I'm sorry, they're V's. Number 21, my x value, there is no number inside with the x, so my x value, my vertex is 0, and the y value, my vertex is out here, the -2, so my vertex is 0, -2. And my rise over run is -1/3, so I'm going to go down and to the right 3, down and to the right 3, and then I'm going to go down and to the left 3. And there's my graph. Number 22, I have a +4 in with the x. That means my x value is -4, and I'm not adding anything out here, so my y value is 0. And then my slope is 2 over 1. So I start at -4, 0, and I go up 2 over 1, and then up 2 and left 1, and there is my V, as badly as I connected those. Okay, now for the last 3 problems. Draw the indicated transformation for each. So here we have a -2 inside, that means it's going to be right 2, and the plus 3 makes it up 3. So each of my points is going to go right 2 and up 3. Right 2, up 3. Right 2, up 3. And this one, I'll erase some of the extra stuff in a second. Right 2, up 3. And right 2, up. Let's erase some of this now.
Sideways full screen. How many times did I tell you?
Let's see. So we can see what's going on now. And then the last one is right 2, up 3.
Turn off table lamp.
And when I connect it, I have the new parabola, g of x. And the next one is negative. This is reflection in the x, and then up 3. So reflection means I'm going to flip it around so that the negative y values become positive y values. So if I reflect it, I'm going to reflect it in yellow. That becomes negative 2, that becomes positive 1, this becomes negative 1, and that one becomes negative 3. And then now I'm going to move everything up 3. So up 3, up 3. Okay, I'm having a hard time hitting the points here. Up 3, up 3, and up 3, and this is your final. This is your final graph, the red. And lastly, this is a reflection in the y-axis, which means your x values are going to become the opposite sign. So this graph is at positive 2, it's going to go over to negative 2. And that's going to stay. This one goes to positive 1, and this one goes to negative 1. This one goes to positive 3, and then the points all move down 2 for this negative 2. So down 2, down 2, down 2, and down 2. And so the red points are my final graph. All right, so hopefully this helps you study for the test.